Quadratic Polynomials at Higher Maths, the whole course, everything in this list, full teaching and all the past paper questions. Let's go. Looking at quadratics first, the discriminant. So this is from National 5 Maths. Given a quadratic equation from ax squared plus bx plus c equals 0, the discriminant is the bit under the square root sign in the quadratic formula. For higher maths, you need to know that, and that's b squared minus 4ac. And there's three things that can happen. If b squared minus 4ac is bigger than 0, you get two real and distinct roots. Roots are where we cut the x-axis. If b squared minus 4ac was equal to 0, you get one real and equal root. So in other words, a repeated root. Or sometimes you can say two real and equal roots. And if it's less than 0, we say there's no real roots, okay? And we can use this in a variety of problems. So here's an example 1. It says find the nature of the roots of 9x squared plus 21x plus 16 equals 0. A is equal to 9, B is equal to 21, and C is equal to 16. B squared minus 4ac. So that's 21 squared minus 4 times 9 times 16. Getting a calculator for that then. 21 squared minus 4 times 9 times 16 is minus 135. So since b squared minus 4ac is less than 0, no real roots. And we're done there. So we can use the discriminant to find unknown terms if we know that the discriminant was real or not real or equal. For instance, example 2 says find the value of q such that this has real roots. So if it's got real roots, we can just say that b squared minus 4ac is greater than or equal to 0 because it has real roots. So remember, that's our a, that's our b, and our c would be q. So just subbing it all in. 12 squared minus 4 times 6 times q is greater than or equal to 0. We need to solve this inequality. 12 12s is 144. So you get 144 minus 4 6s is 24. 24q is greater than or equal to 0. So that means that 144 is greater than or equal to 24q. So dividing by 24, you get 6 is greater than or equal to q, or reading that backwards, q is less than or equal to 6. And we're done there. Okay, a further example like that. Example 3 says show that 2k plus 4x squared plus 3k plus 2x plus k minus 2 always has real roots. So we have to prove it's got real roots this time. So let's do our a, there's our a, there's our b, there's our c. So subbing it in, we've got b squared minus 4ac. We're just going to see what we get. Well, we've got 3k plus 2, all squared, minus 4 times 2k plus 4, times k minus 2. So we need to, I suppose, collect like terms and check that this has real roots all the time. So how are we going to do that? Well, if it's got real roots all the time, it means it could be a perfect square. If it's a perfect square, it means it could be square rooted. So we're going to complete the square essentially. So we expand the bracket, 9k squared. 2 3s are 6, so I double that to get 12k plus 4. And then expanding the second bracket quickly, we get 2k times k is 2k squared, minus 4, so minus 8k squared for the squared terms. And then the k terms, we've got minus 4k, but plus 4k, so that's 0. So 0k terms there. And then we've got 4 2s are 8, so that's minus 8 times minus 4 is 32. Plus 32. Collecting the terms, we get k squared plus 12k, and 4 plus 32 is 36. So now we can try and factorise that because we've got k plus 6, k plus 6. Well, that's the same as k plus 6 all squared, which is a complete square. So since it is a complete square, we can then just say, that k plus 6 squared is a square number. Therefore, b squared minus 4ac is always greater than or equal to 0. And therefore, the quadratic always has real roots. And we're done there. So that's section of lines and parabolas. So there's two things I can imagine. We've got a parabola. Here's some pictures here of parabolas. Obviously a line could intersect it either twice, or at one point, or not at all. Now, if it was to intersect it twice, that means it's meeting it at two distinct points. So if we were to put the equations of them equal to each other or sub in, solve them simultaneously, then b squared minus 4ac would tell you whether it meet at 2 points, because you would get it greater than 0, or if b squared minus 4ac gave you only one solution, it means it has to have only touched at 1 point. And obviously if b squared minus 4ac was less than 0, it means there's no solutions, no real roots anyway, which means the line can't be touching the parabola. Otherwise, there would be a point that we can find. Example 1, intersection of lines and parabolas, says find the coordinates of the points where the line with equation 2x plus 1 intersects the curve with equation x squared minus 2. So we've got two lines with a y and a y, so we can just set them equal to each other. 2x plus 1 equals x squared minus 2, and solve that quadratic. So we've got x squared minus 2x, then minus 2, take away 1 is minus 3, equals 0. Taking everything up the same side. So now we check if it's factorizable. So x and x, 3 and 1, minus 3 plus 1 is minus 2, so therefore x equals minus 1 is one place it touches, and x equals 3 is the other place. We'll want the coordinates also, we'll sub into y, so when x equals minus 1, y is minus 2 plus 1, which is minus 1, so the first point is minus 1, or y equals when it's 3, 2 3s are 6, plus 1 is 7. 3, 7 is the other point of intersection. Intersection of lines and parabolas, example 2. It says show that the line with equation y equals 5x minus 2 is a tangent to the parabola and find the point of contact. So if it's a tangent, it meets it at 1 point, and therefore b squared minus 4ac is equal to 0. So let's just check the point of contact. We can say that 2x squared plus x is equal to 5x minus 2. So that gives me 2x squared. Taking the 5x is minus 5x, so that's minus 4x. Minus 2 becomes plus 2. And now we check, is there a common factor? Well, there is, so I can take 2 out, x squared minus 2x plus 1. And then either to check to check that it's a tangent, we can check b squared minus 4ac, or just factorize it and show it as only one root. Either of the options, but since we have to find the point of contact, we might as well just go ahead and do this. But just at the side, if I check b squared minus 4ac, you get, for the original equation, 2x squared minus 4x plus 2, so that's minus 4 squared, minus 4 times 2 times 2, that's 16, minus 16 equals 0, therefore 1 point of contact. I would just get the roots this way and go, you've got minus 1, since it's a repeated root, we can just then say that that implies tangent. Okay, and then we just solve it. So x minus 1 equals 0, so x equals 1, and then subbing that in to here, 5 minus 2 is 3. Y equals 3, so the point is 1, 3, and we're done there. Solving quadratic inequalities. A quadratic inequality can take one of these forms that I've already written down. It's either going to be the quadratic is greater than 0, greater than or equal to 0, or less than 0, or less than or equal to 0. And solving a quadratic inequality is a bit like solving a quadratic equation, except there's a little bit of an issue where if we just find the roots, we don't know whether it is greater than or less than these roots. So there is a little bit of a method. But so if we draw a quadratic, we can either draw one going like this, where that means that a is positive, or one going like this, which means that a is negative. Now, if we want the quadratic in this case to be bigger than 0, we're just looking above the x-axis because it's above the roots. And in this case, then this quadratic will be greater than 0 when x is bigger than that number going to the right, or less than that number. But it would be below the x-axis when it's in between these two. And similarly, For one that's upside down, the quadratic is greater than 0 between these two roots, but it is less than 0 to the left and the right. And for each question, all we'll do is find the roots, draw a picture, and just look where it's above or below the x-axis. So example 1 says, solve x minus 3x plus 5 is greater than or equal to 0. So the first thing we do is just find our roots as normal. So to find our roots, we make it equal to 0. And this is a simple one. That means that x equals 3 or x equals minus 5. And now this is where the solution changes for higher maths. We know our roots, so if we just draw a quick sketch of this quadratic, it is a U shape, and we've got minus 5 on one side and 3 on the other. And then just to solve our quadratic inequality, we just go back to the original question and said greater than or equal to 0, so I'm thinking about it being above the x-axis. Well, this quadratic inequality, this quadratic's above the x-axis, that side and that side, because in between it's below the x-axis. So I can just write down that x is less than or equal to minus 5, or x is greater than or equal to 3, and that's our two solutions. So in quadratic inequalities, example 2 says, solve x squared minus 4x minus 21 is less than 0. So the first thing we always do is examine our roots, just do our national 5 stuff. X squared minus 4x minus 21 is equal to 0, which means I can hopefully factorize this. X and x, 7 and 3. Minus 7 plus 3 is minus 4. So x is equal to minus 3 or x is equal to 7 as our roots. So we can now draw a picture. We've got minus 3 on one side. That's just a quick sketch, 7. And we'll just draw our parabola. There's our 7 there, so let's just move that because I've just messed our drawing up. Y and x, and the question's asking us, when is it less than 0? Well, less than 0 is below the x-axis, here. In other words, between minus 3 and 7. So we just write minus 3 is less than x, is less than 7. And don't put the equals ones on it because it's not in what and equals, it's just what and when it's less than. And we're done there. Solving quadratic inequalities, example 3. Solve 4 minus 9x squared is less than 0. Okay, so we want our roots. So our roots are 4 minus 9x squared is equal to 0. Well, that's the difference of two squares. So I can just factorize that straight away. 2 minus 3x, square root in it, and 2 plus 3x equals 0. So that means 2 minus 3x equals 0. Or 2 plus 3x equals 0. Solving the left-hand side one, 3x equals 2, so x is 2/3 is one of our roots. Or 3x is minus 2, so x is minus 2/3 for our other root. Drawing a quick sketch. So we've got it between minus 2/3 and 2/3. Now you need to get your shape right. It's a negative 9x squared, so it's a upside down one. We'll draw it upside down. And then we say we want it to be less than 0. So it's below the x-axis. Well, this one's below the x-axis to the left and to the right, because in between it is above. So we can just say that x is less than minus 2/3 or x is greater than 2/3, and that's us done it. Solving quadratic inequalities. Example 4 says find the values of q such that this quadratic has non-real roots. If it's not got real roots, that means that b squared minus 4ac is less than 0. b squared minus 4ac is less than 0 for no real roots. So we just then sub in b squared minus 4ac. So there's my a is equal to 1. There's my b in front there, and there's my c. So I've got q minus 4 squared minus 4 times 1 times a half of q. And we're going to solve that to be less than 0. So we've got a quadratic inequality, hopefully. Q squared minus 8q, and 4 4s are 16. And then 4 times a half is 2, so that's minus 2q, and that's less than 0. So that's q squared minus 10q plus 16 is less than 0. And we can see if we can factorize that. So double brackets, q and q, 8 and 2, minus 8 minus 2 makes minus 10 is less than 0. So a quick sketch on the side. Minus 8, minus 2. There's our quadratic, and we want that to be less than 0. So that is below the x-axis, so that's in between these two numbers. So we can just say that minus 8 is less than q is less than 2. Solving quadratic inequalities, example 5, where is y equals a half, a third x cubed plus 2x squared minus 5x plus 3 increasing. Okay, so this kind of combines quadratics or polynomials with differentiation, because we know that a function is increasing when the y by the x is greater than 0, means it is increasing. Remember, if it equals 0, it means it's a 0 gradient, and if it's negative, it means it would be decreasing. So the y by the x, that is 3 times a third is 1, x squared. 2 2s are 4, plus 4x, minus 5, and we want that to be greater than 0. So we can just solve that quadratic inequality. X and x, 5 and 1, plus 5 minus 1. So our roots are x equal to 1 or x equal to minus 5. So we can draw a picture. It's a positive x squared. So let's put a minus 5 and 1. My pictures are very inaccurate, but it doesn't have to be accurate because it's just a quick sketch. Want to be greater than 0, it's above the x-axis. What's above the x-axis? This side, because it keeps going that way, and this side. So that means that x is less than minus 5, or x is greater than 1. And we're done there. Polynomials. So what is a polynomial? It's just an expression that takes this form. In other words, something x cubed plus something x squared plus something x plus a number is a polynomial, okay? And of course you could have x cubed but no x squared term, but essentially it's just as long as your variable, your x or your y or your a is raised to powers, we call that a polynomial, as long as it's got a whole number exponent, okay? For example, 3x squared plus x cubed plus 2x squared minus 6 is a polynomial. We say the degree is the highest power that the polynomial takes. So in this case, the degree is 5 because the highest power is 5. Quadratics obviously always have a degree of 2 because the highest power is squared. And cubics would have a degree of 3 because the highest is 3. Constants are polynomials of degree 0 because x to the power 0 equals 1. So we're going to do this little task just to make sure we understand what a degree is. And we'll do it together. So the first one says 4x squared plus 2x plus 5. Well, the degree is 2 because of the x squared. 4x4 minus x cubed, blah, blah, blah. Well, the degree is 4 because the highest power is 4. The next one, the degree is 2 because the highest power is 2. The next one, 2x plus 1. Well, the power on x is just 1, so the degree is 1. X minus 1 to the power of 4. Well, if you expand that, the highest power would be 4, of course. So the degree is 4. 3x squared plus 2x to the 5. Well, the degree is 5. We can evaluate polynomials using substitution. So, for example, if we had 2x cubed minus 9x squared plus 2x plus 1, and we want to evaluate the function f of 5, it just means sub in 5. So I could sub 5 in directly and get an answer which is 36. But what that actually means is, if we were to divide this polynomial by x minus 5, the remainder would be 36. Well, why is that? Because if we put a number into a polynomial and we get an answer of 0, it means it's a root, okay? If you imagine back at quadratics, now I had x squared plus 3x plus 2 equals 0, and we're trying to solve that. What we would say is what value of x makes this 0, right? So if you get any other number other than 0, it means you've got a remainder. So here's an example. Given that g of x is this polynomial, we have to evaluate this and state the remainder. So let's do part A. G of 3, just subbing it in, we get 3 cubed plus 3 squared minus 22 times 3 minus 40. 3 cubed plus 3 squared minus 22 times 3 minus 40, that's minus 70. Therefore, the remainder is minus 70. B, g of minus 5, well that is going to be minus 5 cubed plus minus 5 squared minus 22 times minus 5, take away 40. Therefore, the remainder is minus 30. And you can do the same thing for the rest. So for question C, g of minus 2, that's minus 2 cubed, minus plus minus 2 squared, minus 22 times minus 2, minus 40. So we've got 0, and therefore the remainder is 0. So if the remainder is 0, that means we've basically found a factor. That's what we're going to go to next. So polynomials, if there's no remainder when you evaluate f of a, that means that f of a equals 0. And that means that x equal a is a root because a goes into exactly and get an answer of 0. And therefore x minus a is a factor of f of x. In the previous example we had this, and g of minus 2 is equal to 0. This just means that x equals minus 2 is a root, and therefore x plus 2 is a factor, because x plus 2 equals 0, we give you x equals minus 2. We can use this to help factorise then this polynomial, because we now know that one of the factors is x plus 2, and then since we've got that, it'll be x plus 2 times a quadratic to get a cubic, and we'll look at how to get the rest of that so we can factorise it completely. But here's a little task to start off with to get used to the ideas of roots and factors. If we know a root, we immediately know the factor. X equals minus 2, the factor is x plus 2. X equals 5, then the factor is x minus 5. If x plus 7 is the factor, x equals minus 7. If x minus 7 is the factor, x equals just 7. If x minus 3 was our factor, then x would just equal 3. Obviously, x equal to minus 3 means we've got a factor of x plus 3. 2x minus 1, well, how do we work that out? Well, if you just make it equal to 0, you'll be able to see it. You take the 1 across and divide by 2, so it's a half. If you've got a third, then that means that the factor is 3x minus 1. And you can see that if you make that equal to 0, because that gives you 1/3. 2/3, then you've got 3x minus 2. And then 4x plus 5 would mean we would have minus 5/4. Okay, we're going to look at finding unknown coefficients. If we have a polynomial with some unknown coefficients, like this polynomial with a p here, and p is some number, a constant, if we divide by some factor x minus h, then we get an expression for the remainder. But if we already know the remainder, let's say it was 0, we can then just solve what we get to find p, okay? Here's a simple example. So it says, given x minus 3 is a factor of this polynomial, find the value of p. So if x minus 3 is a factor, that implies that f of 3 equals 0. In other words, the remainder is 0. So we can just sub in 3 and then make it equal to 0. So f of 3 is equal to 3 cubed minus 3 squared plus p times 3 plus 24, and that equals 0. 3 3s is 9 times 3 is 27, minus 9 plus 3p plus 24 equals 0. So 27 minus 9 is 18. 18 and 24 is 42. So we get 3p plus 42 equals 0. And therefore 3p equals minus 42. So p is minus 42/3, which we can simplify to 3 into 4 goes 1. 3 4s is 12 minus 14. And we're done there. Second example on finding unknown coefficients. Example 2 says f of x is px cubed plus qx squared minus 17x plus 4q. It says it's divisible by x minus 2 and the remainder is 6. And it also tells us another option, x minus 1 is a factor of f of x. Find p and q. So it's given us two options because there's two things, p and q. So we'll just use both, and then we're going to set up simultaneous equations. So let's use the first option, x minus 2. When it's divisible, x minus 2 is going to 6. That means that f of 2 is equal to 6. So we can just sub that in. We've got p times 2 cubed plus q times 2 squared minus 17 times 2 plus 4 times q equals 6. There's our first thing. Now we can just tidy that up. 2 2s are 4 times 2 is 8p. 2 2s are 4, 4q. 2 17s is 34 plus 4q equals 6. That's 8p plus 8q. I'll just take a 34 over to make 40. So there's one of our equations. Let's get our second one. X minus 1 is a factor, so that means that f of 1 equals 0. The remainder is 0, so we can just shove 1 in. So we've got p times 1 cubed plus q times 1 squared minus 17 times 1 plus 4q equals 0. Well, that gives me p here plus q minus 17 plus 4q equals 0. So that is p plus 5q equals 17, taking the 17 over. Two equations, and now we can just do simultaneous equations. 8p plus 8q equals 40, and p plus 5q equals 17. So we can either eliminate the q's or eliminate the p's. I'll just eliminate the p's by timesing this one by 8. So that gives me 8p plus 8q is equal to 40, and 8p plus 40q is equal to, call that 1 and 2, and we're just going to do 2, take away 1. So that gives me 40 minus 8 is 32q, and 136 minus 40, 96. So therefore we can just say that q is 96 over 32, which is 3. So we've got our q, so we can just sub it back in. So we knew that p plus 5q was equal to 17. So p plus 5 times 3 equals 17. P plus 15 equals 17. So p must equal 2. And we're done there. Okay, factorising polynomials. Example 1. Show that x plus 5 is a factor of this, and then factorise it fully. Now we're going to look at something called synthetic division. If you want to know that something's a factor, we need to show the remainder 0. Now we can put it indirectly, but synthetic division really helps with this. So how synthetic division sets up is you set up a little table, and the coefficients of the polynomial go on the top, but it has to go in order cubed squared. So if there's no squared, you put a 0. So I've got 1x cubed, 9x squared, 23x, and 15. And we're showing that x plus 5 is a factor, so we're subbing in minus 5. So this is how this works. I'll use a different colour pen for this. The first step, the 1 just drops down, and then we times minus 1 by 5 to get minus 5. And then we add. 9 minus 5 is 4. And then we times. 4 times minus 5 is minus 20. And then we add. 23 minus 20 is 3. Then we times. 3 times 5 is minus 15. And then we add, and we get 0. So we can then say, since f of minus 5 equals 0, x plus 5 is a factor. That's all you need to write. Or since the remainder is 0, x plus 5 is a factor is another thing you can write. Good thing about this method, which is called synthetic division or the table method, is that it leaves you with a new polynomial. So you can then just say that you've got x squared plus 4x plus 3. Powers went down by 1, started with a cube. And that's going to be times by the factor that we just started with, x plus 5. So we can now factorise it because we've now got a quadratic. So we get x plus 5, double brackets, hopefully, x and x, 3 and 1, plus 3 plus 1, and we're done there. Factorising example 2, factorise fully this cubic. Now, the problem with a cubic is we need to know one factor first, or a root. And the easiest way to do that is just to sub in numbers until we get an answer of 0, because that means that you've found a root and you've found a factor. So you just trial and error here. You start with 1, then minus 1, 2, then minus 2, 3, then minus 3, and so on. I'll do a few for you. So when x equals 1, we get 2 times 1 cubed plus 5 times 1 squared minus 28 times 1 minus 15. But that equals minus 35. So x equals 1 is not a root. So we try x equals minus 1, and you get 2 times minus 1 cubed plus 5 times minus 1 squared minus 28 times minus 1 minus 15, and that would give you an answer of minus 8, just 18. So that's not a root either. And eventually you try 2 and minus 2. And usually a higher maths, you'll not have to go past 3, right? Unless it's going to be nasty. So don't worry, if you're not getting the answer, just keep going until you get 0. So I'm going to keep going, and eventually I'll try 3. When I try 3, I'll get 2 times 3 cubed plus 5 times 3 squared minus 28 times 3 minus 15. Now let's actually do that sum this time. 3 3s are 9 times 3 is 27 times 2 is 54. 3 squared is 9 times 5 is 45. 3 times 28 is 3 30s is 90, 3 2s is 6, it's 84. So it's minus 84 and minus 15. 54 and 45, well that's going to be 94, 99. So that's 99. 84 and 15 is also 99, so that equals 0. Therefore, x equals 3 as a root. So x minus 3 is a factor, remember. Just a note, I find subbing in directly the quickest way, but you can use synthetic division when you're subbing in as well. And you're going to have to do that anyway once you've found one. So I found x equals 3 as a root, so I put 3 in, it's a root you put in, remember. And the polynomial was 2x cubed, 5x squared, minus 28 minus 15. Minus 28x minus 15. So we're going to end up doing this. We know we're going to get 0 in this last position. So this is a double check for us. So we take the 2 down. 2 times 3 is 6. 6 plus 5 is 11. 3 11s is 33. 33 minus 28 is 5. 5 3s is 15. 15 minus 15 is 0. And therefore we've got x minus 3, remember. And then we've also got 2x squared plus 11x plus 5. So that's has now got it down to there. And then we need to try and factorise this bit. Now sometimes this will be factorisable and sometimes it won't. One quick way to check if it's factorisable is you do the discriminant. But let's just double check anyway. We've got x minus 3. I know this is factorisable. You get 2x and x in the first position. And two numbers at times together to make 5 is 5 and 1. So 2 5s is 10 plus 1 is 11. So it's just 5 here and 1 here, plus and plus, and we're fully factorised. So finding roots. Example, given that f of x is x cubed minus 37x plus 84, show that x equals minus 7 is a root, and therefore solve f of x equals 0. So for solving it, it just means we're solving the equation that we end up with. Now, you could sub minus 7 indirectly, but I find that the only reason to ever sub indirectly is to find a root initially, a small one like 1, 2, or 3, or if there's two unknowns, and then it's easier to sub indirectly than it is to use the synthetic division. Otherwise, I'm going to always use synthetic division because it's just much quicker. So I do my setup synthetic division. Minus 7 is what I'm subbing in. We've got 1x cubed. Now, careful here, we've got no x squared, so I write 0, then minus 37x plus 84. So you need that 0 because there's no x squareds. Take the 1 down. 1 times minus 7 is minus 7. Add them to get minus 7. 7 7s is 49. 49 take away 37 is 12, I think. And then 7 12s is 84, but it's minus 84. And add them to 0. So I can just say that since f of minus 7 equals 0, x plus 7 is a factor. Or you could say that since the remainder is 0, x plus 7 is a factor. That's fine as well. Now we can just go ahead and factorise this. X plus 7 times x squared minus 7x plus 12. But we have to solve that equal to 0. So we'll just say equal 0. And then it's just hopefully we can factorise. So we've got x plus 7, double brackets, x and x. 3 and 4 make 12, but add to make 7, so it's 3 and 4, 4 and 3, whatever. So minus 4 minus 3. So then we can just say x equals minus 7 for the first one, x equals 3, and x equals 4. And we're done there. Okay, determine the equation of a graph. If we've got the roots, then at least another point in the graph, we can find the graph's equation. Because if we've got the roots, then the graph's equation is simply f of x equals factor times factor times factor. But it could also be times by some sort of number, because a number in front of the roots doesn't change it. So we need a point to determine that. So here's a simple example. It says, find the equation of the cubic shown in the diagram, and I'm going to give you the points that they give us in this question. So let me just note these on. They tell us that this is minus 6, that this is minus 3, that this is 1. They also give us 1 point way down here, and they define that point as 0 minus 36, which we're going to need in a minute. So now, since we've got our roots, we can immediately say, here's our roots. Our roots are x equal minus 6, x equal minus 3, and x equal 1. So therefore, we've got our factors. We can write our factors: x plus 6, x plus 3, x minus 1. And therefore, we're almost done. F of x must equal, I'll leave a little gap, but it's x plus 6 times x plus 3 times x minus 1. But it could also be times any number you want, because if that was that equal to 0, the k in the front, the number in front wouldn't make a difference when you factorise. So we need to write k. We need to work out this k, but that's okay, because we know that when x is 0, y is minus 36. So we just sub in 0. F of 0 equals minus 36 from that point. So that gives you k times 0 plus 6, 0 plus 3, 0 minus 1 equals minus 36. Just solve that. It gives us k times 6, 3 and minus 1 equals minus 36. 6 3s are 18 times minus 1 is minus 18. So minus 18k equals minus 36. So k is equal to 2. So that means that f of x, to answer the question, is 2 times x plus 6, x plus 3, x minus 1. Obviously, the order of these brackets are not important at all. In the equation we're graphing, we've got repeated roots. If a repeated root exists, then the stationary point is also on the x-axis. And what that means is, we should know this already, a repeated root means it's essentially two roots which are the same. Okay? So the two factors are equal. So here's an example. Find the equation of the cubic shown in the diagram. There's our roots there, and there's another root there, and then it gives us a random point, remember, so we can work out k. So step 1, looking at our roots, we have got x equal minus 2 and x equal to 3, which is repeated. So that means our factors are x plus 2, x minus 3, and x minus 3 again, because it's a repeated root, because it's a turning point right here. So we can now say straight away that f of x is equal to k, some number, times x plus 2 times x minus 3. And you can write x minus 3 again. Oh, I did have halves here. Let's write squared. Now we can just sub in our point. So the point is 0, 9. So when x is 0, y is equal to 9. So that gives us k, 0 plus 2, 0 minus 3 squared equals 9. Solve that equation. So that is k times 2 times, well, minus 3 squared is 9, and that equals 9. So 18k equals 9. Should be obvious then that k is equal to a half, 9 over 18. So now we just write our answer. F of x is equal to 1/2 of x plus 2 x minus 3 all squared. And that's us done. A section of two graphs. So if we have got two equations of graphs, we can find the point of intersection. We've already done this in straight lines in National 5 and quadratics and straight lines in the quadratics previously in this video. But two graphs can have several points of intersection. One point of intersection or none. So here's a couple of examples. Let's say we had this big random graph and we had a straight line going through it. You see it's cutting at 1, 2, 3 and 4 places. Or we could have this quadratic graph and it's just a tangent touching at one point. Or we could have this sort of graph here where the line, this is just the x-axis, is not touching at all. So here's an example of finding points of intersection. Find the coordinates of the points where the curve y equals x cubed minus x squared intersects with the line y equals 5x plus 3. So if we find the intersection of two graphs or two equations, it's always simultaneous equations. So it's simultaneous equations. So since it's both y equals, we can immediately just say that x cubed minus x squared equals 5x plus 3 for the point of intersection or points. So that is a cubic, so we need to make it equal to 0, anything above a squared. So that's minus 5x minus 3 equals 0. So we've got a cubic to solve, so we need to find the factor. Finding factors, we'll try 1, try minus 1, 2 minus 2, and so on. So when x equals 1, we get 1 cubed minus 1 squared minus 5 times 1 minus 3. If you do that sum, you get minus 8, so 1's not a root. If you try minus 1 though, you get minus 1 cubed. Take away minus 1 squared, take away 5 times minus 1, take away 3. That's minus 1 again, plus 5 minus 3. Well, minus 1 is minus 2, minus 3 is minus 5, so that's 0. So since we've done that, so we know the remainder is equal to 0, and therefore x equal to minus 1 is a root, and therefore x plus 1 is a factor. So now we can do our synthetic division as normal. Minus 1 was the root, and then we've got 1x cubed, 1 minus 1x squared, minus 5 minus 3. Drop the 1 down, then 1 times minus 1 is minus 1. Take away gives you minus 2, times gives you 2, take away gives you minus 3, times gives you 3, and you get 0. And therefore we've got our x plus 1 times x squared minus 2x minus 3 equals 0. X plus 1 or there'll be no solutions. B squared minus 4ac would be negative, would tell you that. X and x, we've got 3 and 1. Minus 3 plus 1 is minus 2. So x equals minus 1, or x equals minus 1, or x equals 3. We've got a repeated root, which means the turning point is on as one of the roots. And now we just need to find the points. So remember, y is equal to x cubed minus x squared, or 5x plus 3. Use one of those equations. So I'll just use y equals 5x plus 3. So when x equals minus 1, y equals minus 5 plus 3. Minus 5 plus 3 is minus 2. So our point is minus 1 minus 2. There's our first answer. And the second one, when x is equal to 3, y equals 5 3s is 15 plus 3, which is 18. So our next point is 3 and 18. And there's our second point of intersection. Okay, looking at factors and remainders, SQA Higher Maths 2015, paper 1, question 3. Show that x plus 3 is a factor of this polynomial and hence factorise fully. A couple of ways you can do this, but the most common way is synthetic division. So looking at synthetic division, you take your coefficients of these. So I've got 1x cubed minus 3x squared minus 10x and plus 24 on the end. And I'm subbing in x plus 3, so I'm subbing in minus 3 because minus 3 is the root. So we drop 1 down. 1 times minus 3 is minus 3. Minus 3 plus minus 3 is minus 6. Minus 6 times minus 3 is 18. 18 take away 10 is 8. 8 times minus 3 is minus 24. And 24 take away 24 is 0. So I can just write a little statement. Since the remainder equals 0, x plus 3 is a factor. Now we're done there. Now we need to factorise fully. So we've all done most of the work. We know that x plus 3 is a factor. So we've got x plus 3. And then we've got x squared minus 6x add 8. X squared minus 6x plus 8. So that's x plus 3, and then from National 5, this is just a double bracket. Two numbers at times together to make 8, but add to make 6 is 4 and 2. I want minus 6 in the middle, so it's minus 4 minus 2, and that's it factorised fully for final answer. Integrating the defined area, SQA Higher Maths 2016, paper 2, question 3. Show that x plus 1 is a factor, and then solve the equation. So that's not integration at all, but we'll do it for the sake of completeness. Then part B says, the diagram below shows the graph of this equation. Write down the coordinates of point A and B, and then calculate the shaded area in the diagram. So we're going to have to do part A to get the coordinates anyway. So part A, show that something's a factor. We can use synthetic division. So for part 1, I'll set up my synthetic division nice and quickly. I've got 2 minus 9, 3 and 14. And we're trying to show that x plus 1 is a factor, so I can sub in minus 1. So I've got 2 minus 2 minus 2 minus 9 is minus 11, times by minus 1 is 11, 11 and 3 is 14, times by minus 1 is minus 14, we get 0, and we'd need to write a little statement. The remainder equals 0, therefore x plus 1 is a factor of f of x. Part 2 of this says to solve the equation then, well, we've now got x plus 1 is a factor, and we've got what's left over, 2x squared minus 11x plus 14. So that equals 0. We should be able to factorise this, hopefully. We've got double brackets. It must be 2x and x. 7 and 2 make 14. So minus 2 times 2 is 4. And then 7 equals 11. So minus 4 minus 7 is minus 11. So we've got x equals minus 1, or x equals 7 over 2, or x equals 2. Part B, the graph cuts the x-axis at A, B, and C right down the coordinates of A and B. Well, we've just worked it out. Our smallest x is A, our next smallest is B. So in other words, A equals minus 1, 0, and B equals 2, 0, and C would be 7 over 2, 0 as well. Part 2 of B, calculate the shaded area. Well, that's integral between these two numbers of our original equation. There's our equation, so it's the shaded area is the integral between minus 1 and 2 of 2x cubed minus 9x squared plus 3x plus 14. So we integrate and solve. So that equals, add 1 to the power, x to the 4 over 4, minus 9x cubed over 3, plus 3x squared over 2, plus 14x, and that is between minus 1 and 2. We then get a mark for subbing in, so let's just sub in our numbers. So tidying this up, that's a half of 2 to the power of 4. 9 divided by 3 is 3, so that's minus 3 times 2 cubed, plus 3 over 2 times 2 squared, plus 14 times 2, so that's our first one, big brackets around it, minus our second one, so that's a half, minus 1 to the 4, minus 3 minus 1 cubed, plus 3 over 2 minus 1 squared, plus 14 times minus 1. And quite often after this point, it gets a little bit messy, but you're getting another mark just for solving that. But if you can get this far, you're doing really well. So let's just try and get this really tidied up. Doing each one separately. 2 2s is 4 times 2 is 8 times 2 is 16. 16 divided by 2 is 8. So we get 8 for our first term. 2 2s is 4 times 2 is 8. 8 3s is 24. So our second term is minus 24. 2 2s is 4. 4 divided by 2 is 2 times 3 is 6. So we get 6. And then 14 times 2 is 28. So there's our first bracket. Minus. Minus 1 to the 4 is 1 times a half is a half. Minus 1 cubed is minus 1, times minus 3 is plus 3. Minus 1 squared is 1, times 3 halves. And we've got minus 14 on the end. Now, you can use a calculator for most of the work on this. I would leave fractions as fractions, but none of this is going to end up being fractions anyway. That equals, using a calculator, tidying up our first bracket, we get 18. And our second bracket, we get minus 9. So it's minus 9. That equals a final answer of 27. So it's 27 as our shaded area, and we're done there. Okay, factors and remainders, SQA Higher Maths 2017, Paper 2, Question 2. Show that x minus 1 is a factor of f of x, and then hence otherwise solve f of x equal to 0. So for part A, we could use synthetic division. So we get 2x cubed minus 5x squared plus 1x plus 2, and we're showing x minus 1 is a factor, which means that 1 is a root, so I'm subbing 1 in. Drop the 2 down, 2 times 1 is 2, 2 minus 5 is minus 3, minus 3 times 1 is minus 3, minus 3 add 1 is minus 2, minus 2 times 1 is still minus 2, and minus 2 add 2 is 0. So since the remainder is 0, x minus 1 is a factor of f of x. And now we have to solve it equal to 0, so we can just straight away say x minus 1, that's our factor, 2x squared minus 3x minus 2 equals 0. And we need to solve that. So hopefully we can factorise the second bracket. So that would be double brackets. And this is National 5 work, so revised factorising if you need to from National 5, but you've got 2x and x. And I'm looking for two numbers at times to get to make 2, so that must be 2 and 1. So 2 times 2 is 4, minus 1 is 3, so it goes this way. And it's going to be 2x plus 1 and x minus 2. Just a double check. Minus 4 plus 1 is minus 3. 1 times minus 2 is minus 2. So that gives the first bracket is x equal to 1, or 2x plus 1 equals 0, or x equals 2. Solving our middle one, we get x equal to 1, or x equals minus a half, or x equals 2, and we're done there. Factorising remainders, SQA High Maths 2018, paper 2, question 7. Part A, show that x minus 2 is a factor, then factorise fully. Then part B is a sequence question. Sequence is not in the course this year, but I'll show part B anyway for the sake of completeness. Show that x minus 2 is a factor of 2x cubed minus 3x squared minus 3x plus 2. So we can set up our synthetic division. We've got 2 minus 3. We've got minus 3 and 2. And it was x minus 2 is a factor, so we can sub 2 in. So dropping the 2 down, 2 2s is 4. 4 minus 3 is 1, 2 1s is 2, 2 minus 3 is minus 1, 2 times minus 1 is minus 2, and we get 0. And therefore, since the remainder is 0, x minus 2 is a factor. And now we can try and factorise it. So we've got x minus 2, this is for part 2. And we've got 2x squared plus x minus 1 from the work we just did up here. That's x minus 2, double brackets, 2x and x. It can only be 1 and 1, so I just need to get my signs right. So it's plus 2 minus 1, so plus 1 and minus 1 here. And that's it factorised for our second mark. Okay, part B of this question is a sequence question, so you can skip ahead if you're just wanting to revise polynomials at the moment. But for the sake of completeness, I'll finish the whole question. So it says the fifth term of a sequence is given by u5 equals 2a minus 3, and it satisfies this recurrence relationship. Show that u7 is that. So we just need to go up to u6, then u7. So for part B, u6 from this bit here is a times u5 minus 1, the one before. A u5 minus 1. So that equals a times 2a minus 3. Take away 1. So u6 is equal to 2a squared minus 3a minus 1. And now we need to do u7. Well, u7 is going to be a times u6 minus 1. So that is a times 2a squared minus 3a minus 1. Take away 1. Multiplying the brackets out, we get 2a cubed minus 3a squared minus a minus 1. And there's our u7. Okay, going on to part C of this question. For this sequence, it is known that u7 equals u5 and a limit exists. Determine the value of a. So let's do part A first. Part 1 first. u5 equals u7. So I can just write u5 again, which was 2a minus 3. So we know that 2a minus 3 on the right equals 2a cubed minus 3a squared minus a minus 1. And we need to solve this equation. So moving everything to the right, we get 2a cubed minus 3a squared minus a minus 2a is minus 3a minus 1 plus 3. 3 minus 1 is 2. So plus 2 equals 0. So we've now got a cubic to solve, so it's actually back to polynomials. 2a cubed minus 3a squared minus 3a plus 2. We've already factorised that. So taking our answer from part A minus 2, 2a minus 1, and a plus 1 equals 0. So that means that a equals 2. 2a equals 1, so a equals a half, and a equals minus 1. And we've solved that. The limit exists, calculate the limit. So this is just a pure sequence question for a limit to, if the limit exists, that implies that minus 1 is less than a is less than 1, and therefore a must equal a half because the other two ones are invalid. The limit is given by b over 1 minus a. So remember, un plus 1 was equal to aun minus 1. We now know that, so b is our last number, so it's minus 1 over 1 minus a half. That's minus 1 over a half, which is minus 2. So the limit of the sequence is minus 2. Basically, Higher Maths 2019, Paper 2, Question 10 for factors and remainders. Show that x plus 3 is a factor. So part A, synthetic division. We've got 3x4, 10x cubed, 1x squared, minus 8x, minus 6, plus 3, so we're subbing in minus 3. So take the 3 down, we get minus 3 times 3 is 9, minus 9, 10 minus 9 is 1. 1 times minus 3 is minus 3, minus 3 add 1 is minus 2. Minus 2 times minus 3 is 6, 6 minus 8 is minus 2. Minus 2 times minus 3 is 6, 6 minus 6 is 0, and therefore since the remainder equals 0, x plus 3 is a factor. Part B, hence always factorise it fully. So we've already done a little bit of the work. We've got x plus 3, and then these all drop down a power, so it's 3x cubed to start with, plus x squared, minus 2x, minus 2. Okay, so we've now got a cubic to factorise, so we need to find a factor of this. You can just do that by trial and error, trying 1, minus 1, and so on. So let's start off by trying 1. So for this one here, we've got 3x cubed plus 1x squared minus 2x minus 2. We try 1, and if 1 doesn't work, we try 2 and 3 until we get the remainder of 0. So 3 goes down, 3 ones are 3, 3 plus 1 is 4, 4 ones are 4, 4 minus 2 is 2, 2 ones are 2, 2 minus 2 is 0. Like again, you might have to do that a few times, and you don't have to use synthetic division each time. You can just substitute a number indirectly if you want, but I've done it in 1, so I now know that since the remainder is 0, x minus 1 is a factor. And therefore, we now know we've got x plus 3, x minus 1, and we've got our 3x squared plus 4x plus 2 from the bottom bit. So now we need to check, is 3x squared plus 4x plus 2 factorisable? There's a couple of ways you can do it, trial and error, but the easiest way is to use the discriminant. If I look at, I'll do this in red, this bit here, and check b squared minus 4ac. b squared minus 4ac is 4 squared minus 4 times 3 times 2. That's 16 minus 12 times 2 is 24, which is negative 8. That means no real solutions. Final answer is x plus 3, x minus 1, 3x squared plus 4x plus 2, and we're done there. Basically, Higher Maths 2021, Paper 1, Question 10 on polynomials, factors and remainders with to factorise 6x cubed minus 13x squared plus 4 fully. So to do this, we need to find one factor. So we just need to do it by trial and error. So first of all, I'll try x equals 1, and we're looking to get an answer of 0. So let's try x equals 1. We get 6 times 1 cubed minus 13 times 1 squared plus 4. So we're just going to have to work that out. 6 times 1 cubed is 6. 13 times 1 squared is 13. And plus 4, 6 plus 4 is 10, that's minus 3. So x equals 1 is not going to give us a factor, so we'll try x equals minus 1. And we'll just keep doing this until we get one that works. So we've got minus 1 squared plus 4. So that's 6 times minus 1, which is minus 6. minus 13 times 1, which is minus 13, plus 4. You can clearly see that that is not going to give us an answer of 0, because you've got minus 19, add 4 is minus 15. So I'll just write that and put it across. So then we try x equals 2. And you just have to keep going, usually 1, 2, or 3, okay? So 6 times 2 cubed, minus 13 times 2 squared, plus 4. 2 cubed is 8, 8 sixes is 48. And then 2 squared is 4, 4 13s is 52. And plus 4, that's good then. 48 plus 4 is 52, minus 52 is 0. Therefore, x minus 2 is a factor. Remainder is 0. So then we can use synthetic division for the rest. So we set up our table. We've got 6x cubed minus 13x squared. We've got 0 x's, so we need to write 0, and then we've got plus 4, and we're subbing in 2. So dropping the 6 down, 6 2s is 12, 12 minus 13 is minus 1, 2 times minus 1 is minus 2, minus 2 and 0 is still minus 2, 2 times minus 2 is minus 4, 4 minus 4 is 0. So we've got x minus 2 times 6x squared minus x minus 2. And now we need to check, is the 6x squared minus x minus 2 factorizable? We can do that just by trying to factorize it, or we can do b squared minus 4ac and check. So let's do b squared minus 4ac on this. So that gives us minus 1 squared minus 4 times 6 times minus 2, that is 1. 4 6's are 24, 24 times 2 is 48. That's 49, so it's factorizable because that's a perfect square. So it's just a little quick check before you jump into it, and it also tells you if it's negative or not a perfect square, it's not factorizable. So we've got x minus 2, double brackets. I can automatically see, I'm just going to trial and error now. So if I try and 6 in x, I get 6 2s is 12 and 1, which doesn't give me the 1 in the middle. And I get 6 1s is 6 and 2, which doesn't give me 1 in the middle. So I know it's going to be 3x and x, but there's lots, 3x and 2x, but there's lots of ways you can do this. 3 2s is 6, 3 1s is 3, and 2 2s is 4. So I'm just doing outside, inside. That gives me the 1 in the middle, and I just need to get my signs right now. So I want to have minus 1, so I want to have plus 3, minus 4. And that's it, fully factorized, and we're done there. SQA Higher Maths 2022, Paper 1, Question 13. Part A, show that x plus 2 is a factor of x cubed minus 2x squared minus 20x take away 24. Part 2, then solve f of x equals 0. And then it shows you a graph of f of x, and it tells you that f of x minus k is k greater than 0, has a station point at 1, 0. You can state the value k. We'll get to that in a bit, but let's start dealing with our showing a factor of a cubic. So x plus 2 is a factor. There's two ways to do this. We could just substitute minus 2 into it, or we can use synthetic division with minus 2, whichever one you prefer. I will do the most common way that most people do it, which is synthetic division. So a reminder of how that works. We put minus 2 on the outside, and then the coefficients of our function. So 1x cubed minus 2x squared minus 20x minus 24. 1 just drops straight down. And then I've got 1 times minus 2, which is minus 2. Adding them together to get minus 4. Minus 4 times 2 is 8. Adding them together to get minus 12. Minus 12 times minus 2 is 24. Adding them together to get 0. And we get a mark at that point for using minus 2 in the synthetic division. So there's a mark. Let's move on to our second mark. So we need to complete the division and interpret the result. So we've completed the division, but we're not actually saying anything. We now need to say that since the remainder equals 0, that therefore x plus 2 is a factor. of f of x, and that gives us our second mark there for completing the division and also making our statement. If you had done it the other way by substituting minus 2 in directly, then you would still get an answer of 0, but you would say that since f of minus 2 equals 0, x plus 2 is a factor. So it's the same way. Okay, let's move on to part 2. Hence or otherwise solve f of x equal to 0. Now, this is where the power of synthetic division comes in. If you've already done synthetic division for part A, you already know this. If you haven't done it for part A, then you're going to have to divide through. But let's just assume that we're doing it this way. So for part 2, we have got this whole bit, x squared minus 4x minus 12 is our factor. So we now know that x plus 2 is a factor. So f of x equals x plus 2 times x squared minus 4x minus 12. And obviously, like I said in part 1, if you had just substituted minus 2 in, then you'd either have to do synthetic division at this stage, or alternatively, if you do polynomial division, if you know how to do that, you can do it that way. But assuming we've done this, we've got the quadratic factor, so we get a mark for stating this point here. That's our third mark. Then we need to solve it, so we make it equal to 0. So we've got x plus 2, x squared minus 4x minus 12 equals 0. That's just staying where it is because we've already done that, but we need to factorise our quadratic. So we've got x and x. Two numbers at times to make 12, but add or take away to make 4 must be 6 and 2. And since our final result is negative, then one of them is negative and one is positive, just getting them right way round. We've got minus 6 plus 2 is minus 4, so that equals 0. If we get to that point, we get our two brackets, we get another mark there. Or alternatively, if you forgot how to factorise or couldn't do the factorising, if you had substituted into the quadratic formula correctly, which would be 4 plus or minus the square root of minus 4 squared, take away 4 times 1 times minus 12, all over 2 times 1, you would get a mark instead for that. And then your final mark is just for working that out to get your factors. So we've now got x plus 2 equals 0, or x plus 2 equals 0, or x minus 6 equals 0. So x equals minus 2, or x equals minus 2, or x equals 6. So we get our final solution of minus 2 and 6 for our other remaining factors, because hence otherwise solve f of x equals 0. We've already got 1. So our other one, forgetting minus 2 and 6. And since it's a repeated factor, we could just say that x equals minus 2 or x equals 6, just to be clear. Minus 2 and 6 give you your final answer mark. The graph of f of x minus k has a stationary point at 1, 0. State the value of k. We know that this must be minus 2 because it's crossing the axis there, and this must be 6. Now, if this has a stationary point at 1, 0, that means that this must have shifted along to the number 1. There's 1 there. It's shifted to the right by 3, and therefore, since it's shifted to the right by 3, k equals 3 because it's x minus k. So it's x minus 3. So k is 3, and we get a mark just for working that out. So there's our final mark for this question. Next, Grey Hand Maths 2023 paper 1, question 10. Show that x plus 5 is a factor of this, and it's a 4th power one, and then hence or otherwise solve it equal to 0. So usually we do cubics, but 4th powers can come up. So you're going to show it's a factor, you're going to end up with a cubic, and you're going to have to then start with a cubic by just guess and check to find another factor. So let's start off showing it's a factor. Easiest way is using synthetic division. So x plus 5 is a factor, so I'm subbing in minus 5. So it's 1x to the 4 plus 3x to the cubed minus 7x squared plus 9x minus 30. So we drop the 1 down, times them together to get minus 5. Minus 5 plus 3 is minus 2. Times it by minus 5 again, you get 10. 10 minus 7 is 3. times by minus 5 again to get minus 15. Minus 15 plus 9 is minus 6. Times it by minus 5 again to get 30. 30 minus 30 is 0. Two options for your statement. You could write f of minus 5 equals 0, and therefore x plus 5 is a factor. Or the alternative is just writing since the remainder is 0, x plus 5 is a factor. Either of the options are fine, but you need to write a statement. Hence, otherwise solve the equation. So part B, we now know that it becomes x plus 5. Then you've got x cubed minus 2x squared plus 3x minus 6 equals 0. We're going to have to check numbers here to find another factor. So the easiest way is direct substitution. So if I try 1, we're going to get 1 cubed minus 2 times 1 squared plus 3 times 1 minus 6. 1 cubed is 1. Minus 2 is minus 1. Minus 1 plus 3 is 2 minus 6 is minus 4. So it's not that one. Try minus 1. You get minus 1 cubed minus 2 times minus 1 squared plus 3 times minus 1 minus 6. Minus 1 cubed is minus 1. Minus 2 is minus 3. Minus 3 is minus 6. Minus 6 is minus 12. So it's not that one. So then you would try 2. And you're just doing it systematically. Once you get bigger, you can go back to synthetic division. I'll stick with this for 2 because it's quite simple. 2 cubed minus 2 times 2 squared plus 3 times 2 minus 6. That's 8. 2 2s are 4 times 2 is 8. Plus 6 minus 6. That's 0. Therefore, we've got another factor of x minus 2. So we're going to have to synthetic division it anyway, but we now know 2 goes in. So synthetic division just on the x cubed minus 3x squared plus 3x minus 6. 1x cubed minus 2x squared plus 3x minus 6. And we're subbing it in 2. Now you could have just done that to the start and done it for 1, minus 1, 2 and so on. We've got 1, 2 1s are 2, minus 2 is 0, 0 again, plus 3, 3 2s are 6, 0. So because since f of 2 equals 0, x minus 2 is a factor. Or since the remainder is 0. At this stage, you don't have to show that it's a factor, so you don't really have to need the statement, but just to be on the safe side. So we've got x plus 3 still, x plus 5 still, sorry, and then x minus 2. So that implies our original function, which is x4 plus 3x cubed minus 7x squared plus 9x minus 30 equals 0 becomes x plus 5, x minus 2, and then we've got, this has become a quadratic x squared plus 0x plus 3, and that equals 0. Now we need to solve it, so each factor becomes equal to 0, so that implies that x plus 5 equals 0, or x minus 2 equals 0, or we could say x plus 3 equals 0. The first one gives us x equals minus 5, second x equals 2, and this one, no solutions, because if you take it over to the other side, you get x squared equals minus 3, and you can't square a negative number. Identifying the coefficients of a cubic, just a quick one on this. SQA Higher Maths, this comes through specimen paper, 2018, paper 1, question 8. For a polynomial, x cubed minus 4x squared plus ax plus b, we know that x minus 1 is a factor, and minus 12 is the remainder when it's divided by x minus 2. determine the values of a and b. So it gives us a couple of bits of information we can just use. So first one, if x minus 1 is a factor, x equals 1 is a root. So we can just sub that in. So we've got x cubed minus 4x squared plus ax plus b. X equal to 1 means when it's 1, we get 1 cubed minus 4 times 1 squared plus a times 1 plus b. All that stuff must equal 0 because x equals 1 as a root. So 1 cubed is 1 minus 4 plus a plus b equals 0. So a plus b we could say equals 1 minus 4 is minus 3. So we get 3. There's one equation. We're obviously going to get another one in a minute and just do simultaneous equations. The other thing is minus 12 is the remainder when divided by x minus 2. X minus 2 gives a remainder of minus 12. So I get 2 cubed minus 4 times 2 squared plus a times 2 plus b. But now the answer that's minus 12 instead of 0. Or you could use synthetic division, but this is probably easier. So tidying that up, we get 8. 2 2s are 4 times 4 is 16. So minus 16 plus 2a plus b equals minus 12. 8 minus 16 is minus 8 plus 2a plus b equals minus 12. So that means that 2a plus b equals minus 12 and 8 is minus 4. And we've now got two equations that we can solve. We've got 2a plus b equals minus 4. And the other equation we just worked out was a plus b equals 3. So we can immediately take them away from each other because the b's are the same sign. 2a minus a is a. Minus 4 minus 3 is minus 7. So we've got an answer of a is minus 7. So that means that a plus b equaling 3 minus 7 plus b equals 3. So b must equal 10 for our second solution. X cubed minus 4x squared plus ax plus b. That's x cubed minus 4x squared. A is minus 7, so minus 7x, and b is 10, and equal to 0. Now remember, in the question here, it already told us a factor, which was x minus 1 is a factor. So using synthetic division on that, we get 1 minus 4 minus 7 and 10. 1 minus 3 minus 3. Minus 3 minus 7 is minus 10 and 0. So that means that we know that we've got x minus 1 and x squared minus 3x minus 10 equals 0. X minus 1, double bracket, x and x. 5 and 2 minus 5 plus 2 is minus 3. And therefore x equals 1, x equals minus 2, or x equals 5. And we're done there. 1 minus 2 and 5. SQA Higher Maths 2016, Paper 1, Question 15. Identify a polynomial from its roots. So the diagram below shows the graph of f of x, which is k, x minus a, x minus b squared. Find the values of a, b, and k. There's one of my roots there. And there's the other root there. That's a repeated root. And I know that because it's a turning point and a root. So that one is my b, and the other one is my a. So I can immediately say for part A, f of x equals k times x minus 4, x plus 5 squared. And then we can use the 0.19 to work out our k. X equals 1, y equals 9. So we get 9 equals 1. K times 1 minus 4, 1 plus 5 all squared. So 9 equals k times minus 3. 1 plus 5 is 6. 6 is 36. So 9 equals minus 108k. So k is 9 over minus 108 minus 12. So we've got k as minus a 12. We've got a equals 4 and b was equal to minus 5. Remember, from our roots, 4 and minus 5. So we're done there. Part B says, for the function g of x equals f of x minus d, where d is positive, determine the range of values for d so that g of x has exactly one real root. Okay, let's have a look at this. If it's got one real root, it only crosses the x-axis at one point. So this is going to move down, so that makes it go, but it's still going up. So this turning point has to go underneath here. So that the only place it crosses is when it first initially drops down. Then it goes up, and it's going to turn before it hits there and go back down. Well, that length is 9, so D must be greater than 9, and it's as simple as that. So it's just really working that out by looking. So for part B, it is right, D is greater than 9, and we're done there. Unusual question, SQA Higher Maths 2018, paper 1, question 15. A cubic function is defined a set of real numbers. X plus 4 is a factor, x equals 2 is a root, f dash minus 2 equals 0, and f dash x is greater than 0 when the graph crosses the y-axis. X plus 4 is a factor means that x equals minus 4 is a root. That's where it crosses the x-axis. X equals 2 is a repeated root, which means that it's also a turning point on the x-axis. That's what happens when you've got a repeated root. So we can start drawing a graph. We can look at the other options in a minute. But if we draw a y and x-axis, just a quick sketch, we've got minus 4 as one of our roots, and we've got 2 is, I'll just put it here actually, as another root. And when looking at our derivatives, f dash of minus 2 equals 0. So we now know that at minus 2 at some point, we've got a turning point as well, not on the x-axis, but then we also know that f dash x is greater than 0 when it crosses the y-axis. So we know that it's going up at this point, but this is a turning point, so it must drop back down. So we now know that it must go like this. And we know that this is a turning point, so it must turn here and go up here because that's a root. So we've got a root, a repeated root, and we're done there. Okay, identifying a polynomial from its roots, SQA Higher Maths, specimen paper 2018, paper 2, question 13. The diagram shows the graph of kx, x plus a, x plus b. It shows the points it's passing through, find the values of a, b, k. So you just need to know that the roots tell you these numbers here. So I've got minus 1, I've got 0, and I've got 2. So let's just highlight that. There's your first root, there's your second root, and there's your third root. So that means I can say that f of x is equal to k times x, double brackets, x and x. First number, x minus 1, so x minus 1, that becomes plus 1 then. And the second number is 2, so it's x minus 2. And now we can go ahead and work out k using our second point here, 1, 2. So when x equals 1, y equals 2. So we get 2 equals k times 1. 1 plus 1, 1 minus 2. So 2 equals k times 1 times 2 times 1 minus 2 is minus 1. So 2 equals 2 times minus 2 is minus 2, minus 2k. So k equals minus 1. A was equal to 1 and b minus 2. Because the form was x and a, so our root told us that minus 1 is x plus 1, so a is 1. And then x plus b, but b is negative because 2, so it's minus 2. Increasing and decreasing functions, SQA Higher Maths 2018, paper 2, question 3. A function is defined as a set of real numbers given by f of x is x cubed minus 7x minus 6. Determine whether f is increasing or decreasing when x equals to 2. So we need to work out the gradient of the tangent at x equals to 2. So f dash x is equal to 3x squared minus 7. At x equal to 2, f dash of 2 in other words, we get 3 times 2 squared minus 7. That's 3 times 4 is 12, take away 7 equals 5. And then we need to write a little statement. Since f dash of 2 is greater than 0, the function is increasing at x equal to 2. And we're done there. SQA Higher Maths 2018, paper 1, question 7 for the equation of a tangent. You've got this curve shown in the diagram. Write down the coordinates of P, the point where the curve crosses the y-axis. So for part A, cuts the y-axis when x equals 0. So subbing 0 in, that's really easy. 0 minus 0 plus 0 plus 5. When x is 0, y is 5, so it's 0, 5. Part B, determine the equation of a tangent to the curve at P. The equation of a tangent, I can find the gradient by differentiation. So dy by dx is equal to 3x squared minus 6x plus 2. And at the point P, P already we know is x equal to 0, y equals 5. So when x equals 0, dy by dx equals 3 times 0 squared minus 6 times 0 plus 2. 0, 0 plus 2 equals 2. So our gradient equals 2, and our point P, remember, is equal to 0, 5. So y equals mx plus c is the easiest one to use here. Y equals 2x plus 5. Or you could use y minus b equals mx minus a and still get 2x plus 5. Question C, find the coordinates of Q, the point where the tangent meets the curve again. So you're just going to solve simultaneous equations here. X cubed minus 3x squared plus 2x plus 5 was our curve. It's equaling 2x plus 5 at points of intersection. So we can solve that quite easily. If these cancel each other out, if we take it over, minus 2x minus 5, they disappear. So that just leaves me with x cubed minus 3x squared equals 0. Common factor of x squared, so you get x minus 3. So that means that x squared equals 0, so x equals 0, or x minus 3 0, so x equals 3. Well, we already know 0 is one of our points, so the second point of intersection is that x equal to 3. So when x equals 3, y equals 2x plus 5. So that is 2 times 3 is 6 plus 5, which is 11. The second point is 3, 11, and we're done there. Completing the square, SPEC Higher Maths 2015, Paper 2, Question 2. The functions f of g are defined on suitable domains by these. First of all, it's a composite function question, but then there's a bit of completing the square at the end. So part A, f of g of x. Well, f of x is 10 plus x, so that's 10 plus g of x. So that's 10 plus 1 plus x, 3 minus x, plus 2. We need to tidy that up a little bit. So I'll expand the brackets. That's 10 plus 1 times 3 is 3, minus x plus 3x is plus 2x, minus x squared plus 2. So that equals 10 plus 3 is 13 plus 2 is 15. So it's 15 plus 2x minus x squared. Or you can write that minus x squared plus 2x plus 15. But I'll just leave it there. Part B, I've got f of g of x equals minus x squared plus 2x plus 15. So taking minus 1 out of the common factor of the first two terms, I get x squared minus 2x. I've still got plus 15 on the end. So that gives me minus 1 x minus 1 squared, half the middle term, and then take away minus 1 squared. I've still got plus 15. So that gives me minus 1 x minus 1 squared, take away 1, plus 15, which is minus x minus 1 squared. Minus 1 times minus 1 is 1, so 1 plus 15 is 16. And that's it in completed square form. C says another function h of x is 1 over f of g of x. What values of x cannot be in the domain of h? So part C, h of x is 1 over f of g of x, which we've just completed the square of, so it's 1 over minus x minus 1 squared plus 16, or otherwise, but the denominator cannot be 0. So we can just write that for the domain, for that to be valid, the denominator cannot be 0. So that implies minus x minus 1 squared So try to solve that equal to 0 to see what that gives me for it. When it is 0, I can then say x can't be these numbers. So we've already completed the square, so we can just say minus x minus 1 squared equals minus 16. Divided by minus 1 means x minus 1 squared equals 16. Square root on both sides, then you get x minus 1 equals 4 or minus 4. So that means x either equals 4 plus 1 is 5, or x equals minus 4 plus 1 is minus 3. That means x cannot equal 5, or x cannot equal minus 3, and we're done there. So that gives us a final answer of 2x minus 2 all squared minus 8 add 11 is plus 3. And we're done there. Completing the square, SQA Higher Maths 2016, paper 1, question 12. Functions f of g are defined on a set of real numbers by f is 2x squared minus 4x plus 5. G of x is 3 minus x. Part A, show given that h of x is f of g of x, show that h of x equals this. So find f of g of x. So f of g of x is equal to, so f of x is 2x squared, so 2 of g of x squared minus 4 of g of x plus 5. So every time I see an x, I put a g of x in, and then I now substitute my g of x. So 2 times 3 minus x all squared minus 4 times 3 minus x plus 5. So we need to expand our 3 minus x squared. So that's 2 times 3 minus x and 3 minus x. Minus 4 times 3 minus x plus 5. Dealing with all of these brackets, we get 2 times, well, we've got 3 times 3 is 9. Minus 3x is minus 6x. And minus times a minus is a plus, so plus x squared. Minus 4 times 3 is minus 12. Minus 4 times minus x is plus 4x. And then we've got plus 5 on the end. So that gives me 18. 2 6's is 12x plus 2x squared minus 12 plus 4x plus 5. So that equals, we've got 2x squared. And then the x terms, minus 12x plus 4x is minus 8x. And then the number terms, 18 minus 12 is 6 plus 5 is 11. 2x squared minus 8x plus 11. Yep, done. Part B, express h of x in the form px plus q squared plus r. So complete the square, in other words. So part B, we've got 2x squared minus 8x plus 11. So that's going to equal, well, we take common factor between the first two terms is 2. So that gives me x squared minus 4x. And I've still got the plus 11 hanging on the end. And then we complete the square with the x squared minus 4x. So that's 2x minus 2 all squared. Take away minus 2 squared. Plus 11. So that equals 2x minus 2 squared. 2 2's is 4, so minus 4, and then plus 11. And then expanding the bracket, we get 2x minus 2 squared. 2 times minus 4 is minus 8, plus 11. That gives us a final answer of 2x minus 2 all squared minus 8 add 11 is plus 3. And we're done there. SQA Higher Maths 2017, paper 2, question 4. Express 3x squared plus 24x plus 50 in the form ax plus b squared plus c. And always completing the square. And then, given that f of x equals this, find f dash x, differentiation. And then hence otherwise, explain why the curve is strictly increasing. So let's start off with completing the square for part A. So we've got 3x squared plus 24x plus 50. So we can just take 3 out as a common factor between the first two terms to get x squared plus 8, x, and then leave the 50 where it is, and then just complete the square on that bit. So we've got 3, and then half the middle term, x plus 4 all squared, and immediately take away the 4 squared. And we've still got plus 50 on the end. So then just expanding the brackets, that's 3 times x plus 4 squared. Now 4 fours is 16. 16 times 3 is 48. So it's minus 48 plus 50. So that's 3x plus 4 squared minus 48 plus 50 is plus 2. And we're done there. Part B says, given that f of x is this, find f dash x. So part B, we know that f of x is equal to x cubed plus 12x squared plus 50x minus 11. So f dash x is 3 in front, x squared, 2 12s is 24x. 50 times x is just 50, and then minus 11 is 0, so we're done there. Question C says, hence allows to explain why the curve with equation y equals f of x is strictly increasing for all values of x. So all we need to do is check, is the derivative greater than 0 for all values of x? Well, the derivative is 3x squared plus 24x plus 50, but that's the same as 3 bracket x plus 4 squared plus 1. So we can say that the derivative is equal to 3 times x plus 4 squared plus 2. Now, we know that x plus 4 squared, if we just take that bit out, is always greater than or equal to 0 for all x. Because to pick a negative number, you square, you get a positive number, right? So therefore, we can then say, well, if that's always greater than or equal to 0, then 3 times x plus 4 squared, well, that's always greater than or equal to 0. But then if you add 2, that must be always bigger than 0 for all x, because you're adding 2. And therefore, with f of x is strictly increasing for all x. And we're done there. SQA Higher Maths 2018, Paper 2, Question 4. Express minus 3x squared minus 6x plus 7 and ax plus b squared plus c. So completing the square on this. So we take our function and we take the common factor out, which is minus 3 of the first two terms. So that gives us minus 3. We've got x squared then plus 2x, because minus 3 times 2 is 6x, and then we've still got a plus 7 on the end. So completing the square on this bit, we get minus 3, half the term, so x plus 1 all squared, and take away 1 squared, 1 times 1. And then we've still got plus 7, so that gives me minus 3, x plus 1 squared minus 1 plus 7, and then expanding that bracket, that's minus 3x plus 1 squared. 3 times 1 is 3, is minus times a minus, so it's plus 3 plus 7. And then finally, our final answer, minus 3x plus 1 squared plus 10. And we're done there. Increasing and decreasing functions, SQA Higher Maths 2019, Paper 2, Question 7. Express this in the form p x plus q squared plus r. Now let's complete the square. So for part A, if we look at these two, we can take minus 6 out as a common factor. So we get minus 6, and we get x squared minus 4x. 6 times 4 is plus 24. Take away 25, sitting on the end, and then we just complete the square the normal way on this term. So we've got, that gives you minus 6, half the middle term, x minus 2, all squared, and then immediately take away 2 squared, and we've still got minus 25 on the end. Just be aware that this is all times by minus 6 though, so we need big brackets around it. So that gives us minus 6, x minus 2 squared. 2 2s is 4, 4 6s is 24. So we get plus 24 minus 25 sitting on the end. So that's minus 6, x minus 2 squared. 24 minus 25 is minus 1. Part B says, given that f of x is minus 2x cubed plus 12x squared minus 25x plus 9, show that it's strictly decreasing. So to show that something's increase or decrease, we need to evaluate the gradient of the tangent, and always differentiate. So let's look at f dash x. F dash x equals 3 times 2 is 6, so minus 6x squared. 12 times 2 is 24, so plus 24x, and minus 25. So we've differentiated it, but notice that is minus 6x squared plus 24x minus 25 is exactly what we were asked to do with something with completing the square on part A. So it's to do with the fact that it's completed the square. So we can now just say that f dash x now equals minus 6x minus 2 squared minus 1. If I pick any number for x here and I square it, I get a positive number. So that means I can then say x minus 2 squared is positive for all values of x. And that means that when I've got a positive times a negative is a negative. Take away another one, gives me a negative as well. So all I need to then say is, therefore, minus 6x minus 2 squared minus 1 is negative for all values of x. So f of x is strictly decreasing. And we're done there. (2022) Higher Maths Paper 1, question 11 was express 2x squared plus 12x plus 23 in the form p, x plus q squared plus r. So in other words, a higher maths complete the square question. So there's a couple of ways to do this. Let's go for the most common way. You've got 2x squared plus 12x plus 23. You want a p, so you're going to have to take 2 out as a common factor between the first two terms. So you could write 2 bracket x squared plus 6x, and then you've still got your plus 23 on the end. And that would be a mark for that. Okay, your second mark, completing the square on this, we have to know that we'll then do 2 bracket half the middle term, so x plus 3 squared. And then we need to, that's all in big brackets of course, we need to immediately take away 3 squared. We've still got plus 23. So if you had got this part here, if you'd written x plus 3 squared times 2, you would have got a mark there. We've got 2 x plus 3 squared minus 9 plus 23. So that's 2x plus 3 squared. 2 times 9 is 18, so minus 18 plus 23, which gives us a final answer of 2x plus 3 squared. 23 take away 18 is 5, so plus 5. So if you can get your final mark by following your working through, you get your final answer there. So that's method 1, that's one way to do it. Okay, another optional method that you could use for this, but not often I've seen taught, is to start from this point and expand it and then equate the terms. I'll show you that method now. So if I've got px plus q squared, that's p times x squared plus 2qx plus q squared, and that is now plus r. Following that through a little bit, I get px squared plus 2pqx plus pq squared plus r. If you got that far, you get a mark at this stage for this method, and then equating the terms. So this obviously equals 2x squared plus 12x plus 23. So we should be able to see the coefficient of x squared here is 2, and the coefficient of x squared here is p, so p is obviously equal to 2. We can see right here that p immediately equals 2. And similarly, the coefficient of x in the first is 2pq, and that equals 12. But we can immediately work out, since p is 2, that means that 4q equals 12, and q equals 3. And finally, we can see that pq squared r is the constant, plus r, sorry, equals 23. But we already know that p is 2 and q is 3, so substituting that in, we get 2 times 9, which is 18, plus r equals 23, so r equals 5 in this case. If you got pq equals 2, 2pq equals 12, and pq squared r plus r equals 23, if you had written down those equations, you would have got a mark. So we should have written all of them, the top lines, and then working all them out and writing it in completed square form gets you your final mark. So you can't just work them all out. You have to then say what the answer actually is, which is 2x plus 3 squared, because q is 3, plus your 5, because r is 5, for your final mark. And there's your 3 marks in that way. SQA Higher Maths 2023, Paper 1, Question 12. Express this in the form ax plus b squared plus c. Complete with square, in other words. So to complete with square, and imagine a dotted line in here, I take out the common factor. So I've got minus 2x squared, then it'll be plus 6x, because minus 2 times 6 is minus 12, but I've still got plus 7 hanging on the end. So I take my minus 2, big brackets, I'm going to complete with square on this, so I half the term, x plus 3 all squared, and I immediately take away 3 squared. But I've still got plus 7 hanging out on the end. So I've got minus 2, x plus 3 squared, minus 9, plus 7. Expanding that, then I've got minus 2x plus 3 all squared. Minus 2 times minus 9 is plus 18, but I've still got plus 7. So I've got minus 2x plus 3 all squared. 18 plus 7 is 25, so plus 25. And we're done there. Looking at the discriminant, SQA Higher Maths 2016, Paper 2, Question 2. Find the range of values of p such that this x squared minus 2x plus 3 minus p equals 0 has no real roots. So no real roots, that means for no real roots we can say that that implies that b squared minus 4ac is going to be less than 0. So our a is equal to the number in front of x squared, so that's 1. Our b is the number in front of x, so that's minus 2. And our c is 3 minus p. So subbing that in, we get minus 2 squared minus 4 times 1 times 3 minus p is less than 0. So that's 4 minus 4 times 3 minus p. That's 4 minus 12, minus times a minus is a plus, so plus 4p. And then that's pretty simple to solve. 4 minus 12 is minus 8, plus 4p is less than 0, so 4p must be less than 8. And therefore p is less than 2. 8 divided by 4 is 2. And we're done there. Okay, the discriminant, SQA Higher Maths 2017, Paper 1, Question 4. Find the value of k for which the equation x squared plus 4x plus k minus 5 has equal roots. So for equal roots, we should know that b squared minus 4ac equals 0. So let's just use that. So our a is 1, the number in front of x squared. Our b is 4, the number in front of x. And our c is what's on the end, k minus 5. So b squared is 4 squared minus 4 times 1 times k minus 5 equals 0. So that's 16 minus 4 times k minus 5. So that's 16 minus 4k plus 20. Minus times a minus is a plus. 16 plus 20, so we get minus 4k plus 36 equals 0. Taking the 4k over, we get 4k is 36, and therefore k equals 9, because 4 times 9 is 36. Okay, the discriminant, SQA Higher Maths 2018, paper 2, question 10. The equation m squared plus m minus 3x plus m equals 0 has two real and distinct roots. Determine the range of values for m. So, two real distinct roots. That implies that b squared minus 4ac must be greater than 0. So in this case, our a is a number in front of x squared, which is 1. Our b is a number in front of x, which is m minus 3. And our c is what's left at the end, which is just m. So being careful, subbing this in, we get m minus 3 all squared minus 4 times 1 times m is greater than 0. So we need to then expand our brackets. So that is m squared minus 6m plus 9. And then 4 times 1 is 4 times m. So minus 4m is greater than 0. So that gives me m squared minus 10m plus 9 is greater than 0. So we need to examine the roots. So looking at the roots, we can try and factorize this. We've got double brackets, m and m, 9 and 1, minus 9 minus 1 gives you minus 10. So the roots have m equal to 1 and m equal to 9. And now we need to draw a graph to examine when is the inequality greater than 0. So that's why we look at the roots. So we'll draw a quick graph. We put our roots on at 1 and 9. We know that the shape goes down the way because it's a positive m squared, so we can just draw a quick sketch of a graph. It doesn't have to be anything too fancy. And we're looking at when it's greater than 0, so I'm looking at when it's above the x-axis. So using a different colour pen, it's above the x-axis over here, and it's above the x-axis over here. In other words, when m is less than 1, or when m is greater than 9. And that's our final answer. Okay, the discriminant, SQA Higher Maths 2019, paper 1, question 2. The equation x squared plus k minus 5x plus 1 has equal roots. Determine the possible values of k. Well, if it's got equal roots, that means that we write for equal roots. That implies b squared minus 4ac equals 0. So our a is a number in front of x squared. Our b is k minus 5, the number in front of x. And our c is just 1. So for b squared minus 4ac, we get k minus 5 squared minus 4 times 1 for a times 1 for c equals 0. Expanding k minus 5 all squared gives me k squared. Minus 5 times 2 is minus 10, so minus 10k. 5 5s is 25. And then we've got 4 times 1 is 4 equals 0. So that's k squared minus 10k. 25 minus 4 is 21 equals 0. And if we're lucky, that will factorize. So we've got k and k. 7 3s is 21 and 7 and 3 make 10. So it's definitely 7 and 3. Minus 7 minus 3 is minus 10. So k equals 3 or k equals 7. And we're done there. SQA Higher Maths 2021, paper 1, question 1. Find the value of k for which the equation kx squared minus 3x minus 4 equals 0 has equal roots. So it's talking about the roots and the nature of the roots, so it's the discriminant. So equal roots, we can write this here, equal roots. That implies that b squared minus 4ac equals 0. So we can find a, b, and c. Well, we've got b squared, that's 3 squared, minus 4 times a, which is k, times c, which is minus 4, and that equals 0. That's 9. 4 4s is 16, a minus times a minus is a plus, so plus 16k equals 0. So 16k equals negative 9. So k is negative 9 over 16. And we simplify all fractions. All the numbers that go to 9 or 9 and 3. Well, 3 doesn't go into 16, so that's simplified. So we're done there. And 2 says, determine the equation 2x squared minus 8x plus 4 minus p equals 0 has 2 real and distinct roots. Determine the range of values for p. So 2 real and distinct roots means that the determinant, in other words b squared minus 4ac, has to be strictly greater than 0. So in this case, a is 2, b is minus 8, and this whole thing here is c, 4 minus p. So we'll just substitute that in. So we've got minus 8 squared minus 4 times 2 times 4 minus p is greater than 0. 64 minus 8 bracket 4 minus p is greater than 0. So 64, 8 fours is 32, 8 times p plus 8p, because minus times a minus, is greater than 0. That gives us 32 plus 8p is greater than 0. Take the 32 to the other side, we get 8p is greater than negative 32. So p must be greater than negative 32 over 8. 8 fours is 32, so p is greater than negative 4. And we're done. Okay. SQA Higher Maths 2023, Paper 1, Question 5. The equation 2x squared plus 3p minus 2x plus p has equal roots. So if it's got equal roots, b squared minus 4ac equals 0. So our a is just the number in front of x squared, which is 2x. Our b is 3p minus 2, the number in front of x. And our c is whatever's left on the end, which is p. So we can do b squared minus 4ac, 3p minus 2 squared minus 4 times 2 times p equals 0. So we need to expand the double bracket. The quick way with a square bracket is square the first. 3p is 9p squared. Twice them times together, so 2 3s are 6, times 2 is 12, so you get minus 12p. And then square the last, 2 2s are 4. So that's our first bracket. Then minus 4 times 2 is 8, times p is minus 8p equals 0. So we get 9p squared minus 20p plus 4 equals 0. Now we need to see if that can factorise. That's a bit of a nasty one. So I'll briefly go over factorising. We do 9 times 4 is 36. I'm looking for factors of 36 that add together to make minus 20, or 20 I suppose. So 1 and 36 is not going to work. 2 and 18 will work, because I can now do minus 2 minus 18 equals minus 20. And minus 2 times minus 18 is 36. So I can split this middle term up into 9p squared minus 18p minus 2p plus 4 equals 0. So then to factorise it, I'll just factorise like this dotted line. So taking 9p out as a common factor, I'll get p minus 2. And on the other side, I'm still needing p minus 2 because I want the same factor. So times by minus 2 to get minus 2p. And just check, minus 2 times minus 2 is plus 4. So then my factorisation is complete. It's what's outside the brackets, 9p minus 2, and the inside p minus 2 equals 0. So 9p minus 2 equals 0, or p minus 2 equals 0. Solving the left-hand side one, 9p equals 2, so p is 2/9. That's our first solution, or p equals 2. And that's our second solution, and we're done there. You're looking at quadratic inequalities, SQA Higher Maths 2015, Paper 1, Question 8. ABCD is a rectangle with lengths x and x minus 2 as shown. If the area is less than 15, determine the range of values of x. Well, area is length times height. So I'll just write that down, or length times breadth if you prefer. So our length is x, and that's x minus 2. And it says that that area has to be less than 15. So I'll just write x minus 2 is less than 15. to set up my inequality. Expanding my brackets, I get x squared minus 2x is less than 15. I've got a quadratic, so I need to take the 15 to the other side, and we need to then find out the roots and draw a graph to see where it's less than 0. So looking at the roots of this, we've got x squared minus 2x minus 15. If that's factorizable, hopefully, we get x and x, 5 and 3. Minus 5 plus 3 is minus 2, so roots are x equal to minus 3 or x equal to 5. So that means we can draw a quick sketch at the side. Minus 3 is over here, and 5 is over here somewhere. It's positive x squared, so our quadratic looks something like that, and it just has to be a quick sketch. Now we're looking to see where it's less than 0, where it's less than 0 below the x-axis. So that is in between these two numbers. Minus 3 is less than x is less than 5. But we need to be careful with this question because it is about the area of a rectangle, so we can't have a negative length. X must be... Let's have a look. We've got x minus 2 is our smallest, so it has to be bigger than 2. Or the breadth would be negative. And therefore, our actual answer is 2 is less than x is less than 5. Need to be very careful with ones where it's in context. SQA Higher Maths 2017, Paper 2, Question 8 on sequences. This time it has quadratics in it as part of the question. So it says sequences may be generated by the recurrence relationships of the form un plus 1 is k un minus 20 and u0 equals 5, where k is a member of the real numbers. Show that u2 equals this expression. Well, u2 is generated by u1. I've not got u1 or got u0. So first of all, for part A, I need to find u1 because it will be k times u0 minus 20. And we know that u0 equals 5. So we can sub in that to get u1. 5 times k minus 20. And now we can find u2 because going up, u2 is just going to be ku1 minus 20, but we know that u1 is equal to 5k minus 20. So we can just sub that in. So that means that u2 is k times the whole of u1, 5k minus 20, then take away 20 on the end. That gives me 5k squared, multiplying out the bracket, minus 20k, and then we've got minus 20 on the end as required. Part B, determine the range of variable for which u2 is less than u0. So part B, if u2 is less than u0, then we can just say that 5k squared minus 20k minus 20 is less than u0, which was 5. And we're just solving a quadratic inequality. So now we're moving away from sequences and moving into quadratic inequalities. So let's just do this for the sake of completeness. We've got 5k squared minus 20k, and taking the 5 over, that gives me minus 25 is less than 0. And we can examine the turning points. So if we have to examine the turning points, that is happening when 5k squared minus 20k minus 25 equals 0. Taking 5 out as a common factor, we get k squared minus 4k minus 5 equals 0. And we can factorize as much as we want to get k and k, 5 and 1. And 5, it'll be minus 5 plus 1. So we get turning points when k is equal to minus 1 or k is equal to 5. So looking at a turning point, we can then just draw a quick sketch of a graph, noting minus 1, noting 5. There's your rough graph. And we want 5k squared minus 20k minus 25 to be less than 0. So we're looking at, if I just draw this in a different colour, it's less than 0 when it's below the x-axis. So it's below the x-axis in between these 2 points. So that happens when -1 is less than k is less than 5. So when -1 is less than k, and which is less than 5, and we're done there. Okay, the discriminant SQA Higher Maths 2018, Paper 2, Question 10. The equation m squared plus m minus 3x plus m equals 0 has 2 real and distinct roots. Determine the range of values for m. So 2 real distinct roots. That implies that b squared minus 4ac must be greater than 0. So in this case, our a is the number in front of x squared, which is 1. Our b is the number in front of x, which is m minus 3. And our c is what's left at the end, which is just m. So being careful, subbing this in, we get m minus 3 all squared minus 4 times 1 times m is greater than 0. So we need to then expand our brackets. So that is m squared minus 6m plus 9. And then 4 times 1 is 4 times m. So minus 4m is greater than 0. So that gives me m squared minus 10m plus 9 is greater than 0. So we need to examine the roots. So looking at the roots, we can try and factorize this. We've got double brackets, m and m, 9 and 1, minus 9 minus 1 gives you minus 10. So the roots have m equal to 1 and m equal to 9. And now we need to draw a graph to examine when is the inequality greater than 0. So that's why we look at the roots. So we'll draw a quick graph. We put our roots on at 1 and 9. We know that the shape goes down the way because it's a positive m squared, so we can just draw a quick sketch of a graph. It doesn't have to be anything too fancy. And we're looking at when it's greater than 0, so I'm looking at when it's above the x-axis. So using a different colour pen, it's above the x-axis over here, and it's above the x-axis over here. In other words, when m is less than 1, or when m is greater than 9. And that's our final answer. Functions f and g are given by f of x is x squared minus 2, g of x is 3x plus 5. We've defined expressions for f of g of x and g of f of x, and then determine the range of values for which f of g of x is less than g of f of x. Let's get straight into it. Part 1, f of g of x equals, so we've got f of x is x squared minus 2, so we've got g of x squared minus 2, and g of x is 3x plus 5. 3x plus 5 all squared, take away 2. 3 3s are 9x squared, 3 5s is 15, times 2 is 30x. 5 5s is 25, minus 2. So f of g of x equals 9x squared plus 30x plus 23. Part 2, g of f of x. Well, g, I remember, is 3x plus 5, so it's 3f of x plus 5. That's 3 times x squared minus 2 plus 5. So g of f of x is 3x squared minus 6 plus 5. G of f of x, 3x squared minus 1. Determine the range of values for which f of g of x is less than g of f of x. So we're saying f of g is less than g of f. So 9x squared plus 30x plus 23 has to be less than 3x squared take away 1. Taking the x squareds across, we've got 6x squared plus 30x plus 23 is less than minus 1. So 6x squared plus 30x plus 24 is less than 0. So we've got a quadratic inequality to solve. So let's look for a common factor. 6x squared plus 5x plus 4 is less than 0. So let's look at the roots of x squared plus 5x plus 4. So that factorises to give us x and x. We've got 4 and 1, plus and plus, so roots at x equal minus 1, x equal minus 4. So we can draw a quick graph to show the roots. Minus 1, minus 4. Less than 0 means below the x-axis. Under here, well, it's under here when it's between these two numbers. So our final answer, minus 4, is less than x, which is less than minus 1.